In this video, we're going to have a look at how to factorize using difference between squares. When we had a look at simplifying by multiplying out brackets, we saw that when you have brackets where only the sign in the middle differs, the middle term will always become 0, so you can only multiply the first and the last in each bracket to get the answer. This answer will always consist of two terms that are perfect squares, meaning they have a perfect square root, and the sign in the middle will always be a minus, a difference, because you multiply a minus by a plus. Now we are going to work backwards and factorize these two terms. So we now know that when you are given these two terms and you need to factorize, you will break it up into two factors of which the sign in the middle has to be different. This will ensure that there is no middle term. Then we're going to take the first term's square root and place that in each bracket, and also take the second term's square root and place that in each bracket. This type of factorization is called difference between squares because the expression has to have a minus in it, difference, and both these terms are perfect squares. Example 1, factorize. Here we are now given two terms which do not have a common factor, but we do have a difference, a minus in between, and both terms are perfect squares. This is why we are going to factorize using difference between squares. As I've mentioned, with difference between squares, you form two brackets of which the sign in the middle has to be different so that we ensure that there is no middle term. Then we take the square root of the first term and place it in each bracket, and the square root of the second term, 4, and place that in each bracket. In example 2, we once again don't have a common factor, but every part of this expression is a perfect square. So we're going to use difference between squares. And for that, we're going to form two brackets with opposite signs. Which of the two brackets comes first does not matter. And now we get the square root of each term. 9x squared has a square root of 3x, which is placed in both brackets, and 100y squared has a square root of 10y, which is also placed in both brackets. In example 3, we're once again going to use difference between squares. But here you need to think very carefully when determining the square root of x to the power of 16. Remember that when determining the square root of a variable, you take the exponent and you divide it by 2. So the square root is x to the power of 8 and not x to the power of 4. Next, when we determine the square root of the constant value 16, it is 4. Now you also need to realize that you can factorize even further. The first bracket cannot be factorized further because it has a plus in the middle. So this bracket stays just like that because for this type of factorization we need a difference in between. The second bracket, however, does have a minus or a difference between two terms that have a perfect square root. So this bracket can be factorized again using the difference between squares method. This is done by starting off with two different signs and then getting the square root of x to the power of 8, which is x to the power of 4, because we divide the exponent by 2. And next we get the square root of 4, which is 2, and that is placed in both brackets. And now we've factorized completely, because the first two factors have a plus in between and cannot be factorized further. And the third factor does have a minus, but the term 2 is not a perfect square and cannot be broken up any further. In example 4, even though we do have a difference, neither 3 nor 27 are perfect squares. And that is why it's important to realize that for any factorization, you always start off by determining whether there's a common factor. In this case, there's a common factor of 3, which we can take out, and then we are left in the bracket with x squared minus 9. The factor of x squared minus 9 can now be broken up further because we have the difference between two perfect squares. So now we're going to add a plus and a minus, and then the square root of x squared, as well as the square root of 9 in each bracket. Let's summarize what we've learned up to now. When you factorize, you always start off by determining whether there's a common factor that you can take out. Next, you need to know that if you have 4 terms, you can use grouping. And when you have 2 terms, you need to check whether you have a minus along with 2 perfect squares, and then you can use the difference between squares method. In the next video, we'll have a look at what happens if you have 3 terms that you need to factorize.